Hi, I'm Sathvik. I'm going to be presenting Unlikely Words in Context, a divergence between humans and large language models. Joint work led by Rosa Lee and with Naomi Feldman. So we're going to be exploring this contrast between humans and machines through findings on how humans process argument roles and show that language models do not show the same systematic patterns that have been observed in human comprehenders. One of the key components of language processing is understand who did what to who. So here in the scene that we have here, we see a waitress with some customers. We might imagine a sentence like, the restaurant owner forgot which customer the waitress served. And now in this sentence, the arguments of the verb served are waitress and customer. But what happens when you switch the order of the arguments to which waitress the customer served? Now, human comprehenders are not immediately sensitive to this anomaly during sentence processing, even if they might eventually get that one sentence is anomalous and the other is good. And the way that this is usually tested, at least in these studies we're going to be going over, is through the N400 ERP potential. It's an index of prediction during language processing as evidenced by a lot of studies before, and here in this figure that I'm actually presenting, where we see this peak around 400 milliseconds for the implausible condition, where people are really surprised by the sentence, it's hard to admit when one is screened, relative to sentences like, it's hard to admit when one is wrong. And the figure that this is from is actually a study by Mikolov and colleagues that shows that measures from language models are quite good predictors of this N400 potential. But before we get into that, let's look into the human findings around these argument roles in language processing, where they respond systematically to different manipulations of argument roles. So these are sentences from older ERP studies, and so we're going to call them swap arguments, change verb, and replace argument. In the sentence, the restaurant owner forgot which waitress the customer served. Customer is the object of served. But if you switch customer and waitress around to get an implausible sentence, which waitress the customer served, customer is now the subject of served. But you can also do the same manipulation in the change verb condition. In the plausible condition, the hearty meal was devoured, meal is the object of devoured, but in the implausible condition, the hearty meal was devouring, it becomes the subject of devouring. And so humans have shown similar ERP effects. No N400 effect in the swap arguments taken from stimuli by Chow and colleagues, but yes for a P600 effect. And this has been shown as well by a study from Kim and Osterhout, which had the change verb condition. So with these two distinct manipulations, they result in the same effect of the argument role. And we see the same patterns during comprehension. But on the other hand, in this other sentence from Chow and al., which we're going to call replace argument, where we have the sentence, the secretary confirmed which illustrator the author had hired versus the secretary confirmed which readers the author hired. We switch illustrators for readers, which is just less plausible based on world knowledge. It's much more likely that the author would hire an illustrator rather than a reader, and people immediately notice the N400. Thus, people might not be surprised because words like waitress, customer, and serve all occur during similar contexts. We also know that the N400 is an index of predictive processing, and we've seen some patterns in these studies before, and we're also able to test this hypothesis if people are just making some faulty predictions based on the context using language models. In particular, they're a useful way to test this hypothesis because they're able to learn a lot of linguistic details simply based off predicting upcoming linguistic information. And critically, in a lot of studies, we see that measures from language models, or mainly the probabilities that they assign to upcoming information, are also indices of predictive processing, whether they are with reading times or, in this case, with the N400. And now we know that humans eventually distinguish the implausible sentences, but our focus is here to show whether this distinction shows up during incremental processing. This is something that we can also test quite effectively with language models because they, again, assign probabilities to each individual item of a sequence, and effectively they can be treated as similar to psycholinguistic subjects. In a sense, we've also seen some recent effects where some recent studies show that language model probabilities are able to predict that one sentence is implausible or more difficult than the other, but they cannot account for the full pattern of results that humans have exhibited. So with this in mind, we're going to be looking at several approaches where we test if the language models show the same systematic types of patterns across these three distinct types of manipulations. Remember, we make swap argument and change verb implausible by changing the argument rule associated with the verb, but replace argument gets made implausible by making the argument semantically implausible and argument role related information doesn't change. So we conducted 3 experiments to evaluate the models. First, we measured how surprising the implausible verbs are relative to the plausible ones. Second, we determined where in the models the sensitivity to roles was emerging. And third and finally, seeing if the models essentially paid attention to the right argument roles in the first place, if they correctly identified the subject or object or agent and patient in the sentence. In our first experiment, we measured the surprisal, which is essentially the probability, the negative log probability of the word given the context. So a high surprisal means that something is more unexpected, essentially. But critically in this study, we're not just asking whether the surprisal was higher in the implausible condition rather than the plausible one. We're asking, to what extent is this the case? And so given these 2 conditions, which waitress the customer served and which customer the waitress served, we would take the difference in the surprisal of served in those 2 distinct contexts to get our effect of surprisal. So I'll briefly be going into some details on the language models that we tested. Most critically, we should know that the GPT-2 family of models across different scales only uses the preceding word as context as a way to model the incremental effects we've seen with the N400, but we also use the BERT family of models because they both use bidirectional context. So they use both forward and backward context to parallel these judgments that show up later on regarding acceptability judgments. And so to summarize, if these language model surprisal-based patterns are exhibiting these effects, we would then see a low effect of surprisal for swap arguments and change verb, and a high effect for replace argument. But let's look into the results now. So on the x-axis, we have plotted the different types of models for each different condition. And on the y-axis, we're going to plot the surprisal effect. It's not exactly what we might see, but let's focus on the successes of the models. Here, we see overall a higher effect of surprisal for replace argument relative to swap arguments, but at the end of the day, change verb is producing a much higher difference in surprisal between the 2 forms of the verb, thus suggesting that the models may not be exhibiting human-like patterns. Then, since we know that the models are able to recognize which arguments are plausible versus implausible, we can basically peer inside the black box, where we see that humans don't recognize this anomaly immediately, but they still think that the implausible sentences are unacceptable. And the way that this is paralleled with language models is that you might see which types of knowledge emerge in which layers. And the reason why some of these models have done so well is because some researchers have found that earlier layers track information related to position, middle ones track information related to part of speech, and so on and so forth. And so critically, I'll show what we're looking for here, but briefly I'll talk about the methods where we take the embeddings or the activations that the model assigns, so you just think of it as a large vector of activations of artificial neurons for the verb at individual layers, put it through a classifier that tells us if the model is getting plausible or implausible information. And we're essentially going to be looking at the accuracy of this classifier across the 3 different conditions. So here's what we might expect. We might see that, like humans, again, the models might be getting lower accuracies on swap arguments and change verb throughout the middle layers, and then they finally get the right contrast, whereas for replace arguments, the anomaly is recognized earlier during processing for the model. But here we find that, again, these plots show that on the x-axis we have the number of each layer, for the model, and now the plots are for each model, and the little lines are for the 3 different conditions. And so the accuracy is plotted on the y-axis, and so if you look at swap arguments and replace argument in blue and gold respectively, you see some pattern that you might expect, where the models don't get this contrast and then the accuracy steadily improves throughout the layers. But critically, for replace argument, which is in green, the model is already getting 100% accuracy, and it doesn't even need to go through all of the layers in the first place, suggesting that the models are using lexically relevant features. We'll get back to this in a minute, but this might also prompt us to ask the question, what if the language models are failing to recognize argument rules in the first place? And we're going to be looking at attention, which was discussed in the talk yesterday as well. We're not going to go into as much technical detail, but one critical thing to remember here is that we talked about layers of the language model before in our last experiment, but now each layer also has individual components that essentially learn weights that say what part of the preceding context is important when generating predictions. And so these are called heads of attention. And here's an example where we have the attention head that's assigning weights to served, and then also its arguments, the waitress and the customer. And so based on some work on agreement attraction from Ryu and Lewis, previous studies in psycholinguistics have used this as a method to essentially track certain mechanisms of attention and relate to empirical findings in humans. And so we're basically trying to look for the attention head that assigns the highest weight to the agent and then compares relative attention to the agent and the patient across the sentence types. So we're going to be looking at both the swap arguments and replace arguments conditions because they both have agents and patients, and in the third experiment, we analyze these attention weights to see if the models are even getting this contrast in the first place. Now, this is interesting since these are the cases where the model showed smaller surprisal effects, but now we know that they still actually learn the right set of argument roles. So not only did the part of the model that attended to the agent also attended less to the patient, where we see attention weights of around 0.2 for patient and 0.5 for the agent, but also we did not see that this weight was degraded in the implausible condition. So the model assigns similar weights, which suggests that the pattern that we're seeing doesn't come from this failure to recognize argument roles, but a failure to use this information in a human-like manner. So to summarize our findings, first, in our first experiment where we looked at the effect of surprisal, so the negative log probability of the verb in the implausible context versus the plausible one, we see that the models are at least getting that the implausible ones are more surprising, but they don't exhibit the same pattern as humans. In our second experiment, where we compared the accuracy of the probing classifiers, which looked at information throughout the layers, we see that there is a change in sensitivity throughout the layers, but not for change verb, which didn't even need to go through the model in order for the representations to be distinct. And third and finally, do the models recognize argument roles? They are, but they're not using the same information in a manner we might expect of a human comprehender. Thus, to add another column to our table here, humans perform similarly on swap arguments and change verb and better on replace argument. Language models perform better on replace argument than swap arguments, but they do a lot better on change verb. So why might this be the case? You've probably been wondering that for quite some time now. There's a couple reasons. So one is this idea of an animacy violation in the implausible condition rather than just making the sentence semantically implausible but still possible in the world, where a customer could be serving a waitress in some context that we might think. And then the other, which is also related to some other work that I've been doing, is how the lexical items are represented. So it's possible that the model could have been learning the role-related information based on the morphological information encoded in the devoured versus devouring as part of the word forms, rather than having to make these inferences during the evaluation process or inference. And so one way to get around this actually relates to some other work I've been doing where we've trained language models on morphological units and show that those are decent predictors of human reading comprehension. And so we might expect a smaller effect for devoured versus devouring under those conditions. And then another interpretation of these results could be that for this set of data, the language model surprisal might not just be capturing the N400 effect, but also a combination of both these effects. And this is consistent with a model from Lee and Futrell, which proposed that the surprisal that a language model assigns can be decomposed into N400 and P600 components, so it would be nice to test the N400 specific component here and see if that gets us different results. Thus, these results overall indicate that even if models are able to distinguish plausible and implausible verbs based on argument roles to some varying degrees of success, the lack of generalization across sentences that share the same structural relation suggests that models do not use the same mechanism as humans to compute argument-verb relations. This overall tells us that just appealing to these predictive mechanisms can't explain these patterns we've seen when humans are processing argument roles. So even if prediction is an important part of the process, we need to be a little bit more firm about the hypotheses and algorithmic commitments we're making based off these results informed by these language models, which are good at estimating probabilities, but as we know, might not extend to all cases of human comprehension. So thank you to my co-authors, Rosa and Naomi, as well as the wonderful broad language science community here at Maryland. And the link to the QR code is actually a paper we had published in the Empirical Methods of NLP conference, but we're also really honored to be sharing this work here in front of psycholinguists. Thank you so much, and I'm happy to have questions.
Hey, my name's Tom Hansen from Tufts. Yeah, I just want to get some clarity on this work. And so is the idea that these language models are doing this next word prediction, and you're trying to draw an inference to what we know about prediction from ERP components? And then the thing I would say is how strong is that connection in your mind? And is the type of prediction those language models are doing, is it using the same sources of information that you think is happening in human language prediction? And just your thoughts on that.
Yeah, so to clarify the goal of the work, we've seen these patterns in ERP data where there is a presence and the presence or absence of an N400 effect. And since we know that the language models are really good at predicting the N400 in other conditions that may not have been this role reverse condition, we're now looking at cases where information about the argument role has been manipulated. So whether it's done by word order or by changing the morphological marking of the verb, that leads to similar manipulations that yield similar patterns in humans. But if you look into the models more deeply, we're showing that it's not the same. And what we mean by that is then wrapping these results back to what we know about the relationship between models and humans. And we say that, okay, these models are some indices of processing difficulty and prediction. And so this tells us that prediction is not everything that we're doing here in this context. And it could also just be the case that the language models are much better models of the language and don't capture these timing-related effects that are very specific to human comprehenders.
Hi, Lisa Levinson, University of Michigan. I'm very sympathetic to the idea that the language models are not doing the same things the same way as humans are, so I'll start with that. But when you say that if we take the swap arguments and you say the human performance is low, by that you mean that they do not have an N400?
Right, they don't see the anomaly immediately, but then they would recognize it later on.
But by later on, we mean within 200 milliseconds, right? So the P600 is there.
Right.
So because for the other sentences, you are arguing that The language model might be reflecting both the N400 and the P600, and we could decompose those. But in the swap arguments, there's also a P600 effect. So I feel like there's, to formulate it as though humans are not sensitive to this when within 200 milliseconds later they are, seems a strange framing, I guess, to me. So I'm wondering if you could say more about that.
Yeah, thank you for bringing it up. And I actually went back to the slide in swap arguments, where we see that the only language model that's getting this effect of zero difference in surprisal, is GPT-2 small, and that's shown to be better at predicting human responses relative to the bigger models. And so it might also tell us that since the other effects are positive for these larger models, especially the ones that are bidirectional, or even like the other autoregressive ones that have learned more information. So it could still be telling us that the surprisal might reflect some P600 component there. And what that would mean, though, is, I think what that would mean is actually looking at the ERP amplitudes and doing some comparisons of these effects and predicting an expected amplitude and from the language model and going back to the neural data.
Right, yeah, so I've done an analysis with the surprisals on the GPT-2 medium with the original ERP data, and it didn't really show a great correlation, but that's what I think you would want to see, is looking at the actual kind of continuous measures modeled together. So it'd be interesting to see. You've done some very different things from the ways I've looked at it before, so that would be interesting to see how those model together, rather than kind of like, here's the differences and here's the ERP data separately, to see them in a model together. Really cool, so thank you.
Hello, Simantika from UNC Chapel. Again, cool talk. Again, that, human processing is different from LLMs. It's always nice to see niche differences. I had a very fundamental question about the role blindedness that happens only for the humans. Do you think this is only serving a very useful purpose in human language processing, or is it just like an inefficiency in human language? And that's why it's not showing up in LLMs.
Right, that was a good question. I'd love to talk more about that and learn more about what you meant by this role blindedness. But I think what that might be showing is that there's other processes that might show up later, which have to do with assembling the whole utterance together, because we see that there is an effect of the P600. So maybe you don't notice the anomaly because you're busy doing some other work, interpreting the sentence compositionally.
Thank you.
Hi. So I guess from my perspective, what's interesting here is not that human beings are different from LLMs, right?
Agreed.
Any two things are different. Maybe what's most interesting is, given what we know about these devices, what might that tell us about people, right? And how can it help us refine our models of human language comprehension? And I think you've already pointed to one thing, right? The biggest difference that you're getting here overall is those green bars, right? They're sky high. And you're saying, okay, well, I think part of what's going on here is that human beings have morphology, and for the model, these are just X and Q. They're just completely different words, I think, right?
Yeah.
And I'm wondering then, so maybe we should really be focusing in on the swap and replace arguments. There where all the information lies, because it's really just the breaking down into words, right, that we're learning from looking at the green bars. And I guess I'm finding myself wondering, how do I scale these? I think I should ignore BERT, right, because you're telling me that with BERT, you just left out the middle word, and so that's not linear. That's not what human beings are doing. If I only pay attention to the linear models, right, well, maybe I should be thinking something about, what the scale, how the scale links up to the N400. Maybe we are doing the same thing, but you got to get above, I don't know, surprisal of 2 or something before you get a detectable N400. Is that a way to rescue this?
Yeah, I think that's a decent interpretation of how these results can be connected with the actual fits of surprisal to N400 data. Again, we're just taking those results, saying that surprisal is a predictor and evaluating the effect, but there's a lot more in-depth modeling that's been done where either by Lee and Futrell, there's like also a lot of other there's like some other more explicit modeling that might involve like specific processes like retrieval and integration using some sort of like neural models. And so possibly hooking up one of these larger models that do better at predicting M400 amplitude to some more explicitly worked out models could be a good direction forward.
Thank you.
Hi, Sathvik. It's Utku from UMD, if you forgot me. It's an amazing talk. Thank you so much. I love it. It was very clear. I wanted to ask you about your speculations about one of the things that you mentioned at the end. You mentioned that one possible reason is the morphological unit marking, right? Maybe this is like also a good place after what I just asked. But so do you think if you had another language, right? So like where you can swap the arguments by changing the case, do you think that would be would you predict that you can basically turn on and off where the LLMs predict better the N400 or not? And additionally, do you know any study for like in these languages that check those swap arguments thing by changing the case?
Yeah, so one direction that we were looking at, Rosa had thought about this when we were like extending these models, was looking at the issues with like case marking in Korean. And so that's how argument roles get assigned. And so if we have like a morphologically segmented Korean corpus where we can train a large enough language model on it, or even like an n-gram model, honestly, like looking at those types of experiments and seeing like what happens if you have morphologically marked case, a surprisal that is assigned to each case marking. I think that would open up a lot of doors in terms of exploring prediction-based accounts of the role of case marking, not just in these cases of role reversals.
And you would predict that then the swap argument should work like change verb.
It should work like, that would be possible.
The picture should be similar.
Yeah.
Okay, thank you.